Okay, so, I mean, I didn't really plan anything. I just talked to you guys because, can I have a 10 for everyone? Because discussion is dependent on the actual experiment, right? So the actual experiment decides what kind of discussion you need to write, okay? So basically, in the notes, like the old notes I got was from Mrs. Johnson, and she said, oh, like what are some assumptions like we made, and then like I don't like that kind of approach. I think for me, a better approach is this. It's basically, right? Basically, you've done so well, right? You've done everything you can for this experiment, but at the end, there's still something you cannot control, right? You can't be 100% correct. And these things that you can't control affects your answer. So at the end, if your one and the theory one are a little bit different, right? Basically, you need to talk about why is it different. What makes it different? And what makes it different is the things you can't control. Does it make sense? Because if you just write something, you can control it, but then you write it in the discussion, I'm like, well, why didn't you do it in the first place? That means your experiment wasn't a good experiment. Does it make sense? But you write the thing you cannot control. For example, I want to use this swing blade as an example. The swing blade example is, can you guys have a think? What are some things that you just cannot control? Air resistance, yeah, but air resistance is not a like great one, because air resistance shouldn't really matter that much, right? It's, if you mention it, maybe we'll give you a weak discussion point if everything else is really great. Yeah.
The amplitude decreasing is more weight is added on.
Amplitude decreasing. So then here's the question: does the amplitude decreasing changing the period? Amplitude decreasing is not supposed to change the period, right? In the period equation, there's nothing changing the period. Okay, let me write down the theory equation first. What was the theory equation? You guys mind reminding me?
T equals the square root of 16 pi squared times d cubed over k times the square root of
D cubed over
k times the square root of
Okay. Okay, let's hear some other ideas. I mean, you can talk about friction, like that just adds a little bit of weight on it, but I wouldn't just give you like a one excellent point just because you talk about friction. Okay. All right. Anything else? Yeah, Rachel. What else?
I was going to say the weight of the blade.
The weight of the blade. Okay, very good. So weight of blade.
I also said center of mass as one of them because like.
Okay, very good.
It can also like sag slightly with the little elastic thing that you put on.
Okay, first let's have a look at these two and say how do we discuss it? Why does it change our result? We actually can go back to the equation we have over here. The weight of the blade was not considered. If we consider the weight of the blade, I mean obviously that changes my independent variable. If it changes my independent variable value, and that's going to change my gradient and my y-intercept. Does this make sense? So you need to link whatever the discussion point you have to the equation, how it's going to change it. So if you so in the old topic, so back in the day, like I think this topic only changed like a few years ago. So I think 2013 is when it changed. So before that, you actually need to talk about how is it gonna increase the gradient? Is it decreasing the gradient? Is it gonna increase the y-intercept or decreasing the y-intercept? But at the moment, you guys don't need to do that. You just need to how it's gonna change the gradient and y-intercept. Does it make sense? Okay, you can see that does changes that, right? Okay, great. Okay, so that's first one. You've made that discussion. Okay, and in terms of exactly how do you write it, it doesn't matter that much. You just need to describe it. Okay, so mostly if I see someone thought about the weight of the blade, I'm just like, you got it, and then quickly have a read. Okay, no problem, and then just give that excellent point. Does it make sense? Okay, so now second one, let's have a think of center of mass. Have a think, how is center of mass is going to affect anything? Yeah.
Because the distance is.
Are you just copying from somewhere?
Hey, no.
Oh, okay.
I just went.
Okay, I'm just thinking. Oh, you know everything. Okay.
The
Yeah.
distance
Yeah.
changes. Like the distance from the.
Okay, very good. Yeah, let's look at the center of mass. How is the center of mass going to change anything over here? When we're measuring this distance over here, we're measuring from the end of the blade to the center mass of the oscillation. Because when we talk about oscillation, it's the center mass that's oscillating, right? So when we measure that distance, where the center mass can change according to how much weight you put on there, especially if you're considering the weight of the blade. You can see how the center mass, the more weight you put there, say you got the weight over here, that is your blade. The more weight you have over here, where does the center mass go? You probably measure the weight just over here, that is the center mass, right? But in fact, the center mass is probably over here because there's a weight of the blade. And the more mass you add here, the more center mass is going to be closer to this value. But you've used this value, you haven't really, because you don't know where the center mass actually is. Does that make sense? Okay, that makes a difference. Say some student might talk about, oh, the clips have the mass as well. Then we'll be like, well, then why didn't you measure the clip's mass and put it into the equation to calculate? Does that make sense? That's not a good discussion point. In fact, that tells you you didn't do a good job. Does it make sense? So you're gonna talk about the point you cannot overcome. Okay. All right. So that's two good ones. Can anyone think of any other ones? Yeah.
Like the angle in which you release the blade from the oscillator point.
Okay. So the oscillator point. How is the angle going to change anything?
Like if you put like if you angle it more, it'll probably like swing more. Isn't it? Like
Eh? How much you put it back? Yeah.
Yeah.
That's kind of like your control variable. You control how much you pull back, right? And then yeah. So that's something you have to do. You pull it to a small angle and release. Okay. You're not supposed to pull it big angle. Big angle not very good. You're supposed to pull a small angle. Yeah. Okay. That if you mention it, like we wouldn't give you points, but we wouldn't deduct any points. Okay. That's a good point. But that is a controlled variable which you probably like level 2 physics. You have to do that. Talk about the control variable. Yeah, so this is more discussion, is more evaluating, say what I've done well, what I haven't done so well, yeah. Okay, and another one is something you will need to observe. So another typical one is when you have a really heavy mass, because of gravity is having an effect, the thing is not gonna vibrate left and right perfectly. Actually, it's gonna swing a little bit like that because of the mass. So that is something you have to observe. Just like when you did the two spring with the cart, if you observe that, oh, the cart's wheel are not rotating or something like that, that can affect. So if there's an actual situation you cannot overcome because of your model has a problem, then you can't change it. Does it make sense? Okay. Because the swing motion. So what is the swing motion? The swing motion is the thing goes a little bit like this. Instead of just bouncing like this, it's bouncing a little bit like this where it has a heavy mass on it. Okay, so that's another situation you can talk about. But I think for this one is you have to talk about this. If you have to talk about it, if you discuss these 2 points, that's it. You get excellence. Okay, and like I said, the excellence discussion point is not the difficult part because these kind of things are pretty straightforward. It's always going to linking back to the thing you have. So, yeah. And I mean, K value is already given to you. So there's nothing you can talk about in terms of K value. But if there's any other value in there, some people will say, oh, I control the gravity constant number. Well, how do you not control the gravity constant number? Do you know what I mean? So, yeah, so that's why you talk about the thing that's actually going to affect your thing. Okay. All right. So I'm going to stop this video now because that's about the discussion part. So